Good afternoon, everybody. March 28th, Tuesday afternoon. This is a live shot here in Texas, looking out to the south, and you can see a lot of cumulus. The tropical feed of moisture coming up from the Gulf of Mexico. We've got 60s dew points coming up from the south, and you can see that hazy look, very typical of springtime here in Texas. So what do we have on the charts? I haven't looked at too much data because I thought it'd be fun to jump in without really looking at anything and build the forecast picture from the ground up. So that's kind of what I'm doing here. So for those of you who are not aware of what's going on in Texas and Oklahoma, you can sit back here with me and watch as I work through the charts. And you can see that the dominant pattern we have is a large cyclone out in New Mexico, large low pressure area. And then on the other side of the picture, out in the Mississippi River Valley, we have high pressure. And you'll notice that the center of the high pressure area is a little bit further, it's kind of to the north. It's not coming out of the Gulf of Mexico like we often see in the springtime. So there's a component of flow coming from the north, from the Ohio River Valley area. So this is helping to infuse some cooler temperatures towards this low pressure area in New Mexico. And then we do see southerly flow coming off the Gulf of Mexico. So it appears that we have at least two different source air mass regions. We have this north one up here. Origin of that air mass is Ohio, the Ohio River Valley area. This is coming from the Gulf of Mexico down here. And then we've probably got a third air mass out to the west, involving maybe some plateau air from New Mexico and Arizona. So we're trying to be aware of that general flow picture of what's happening, because that's what's going to define a lot of the boundaries we have today. Okay, and you can see we've also got thunderstorms going up around the Lubbock area. And for now, they're not formed up into lines. So they've got a discrete cellular appearance. And you have to go up here in the Amarillo area for that to start joining up as a line. Let's look at that on more detail in the Lubbock radar. And it looks like we've built in a little bit of that convection further south towards I-20. Quick look at some of the strongest thunderstorms. It's got kind of a messy, slightly disorganized look, and it definitely looks multicellular, like a multi-cell line. And if we go up to higher tilts, we don't have a whole lot of overhang developing just yet. Like on here, the tail end, on this storm here, the overhang right there. I'm going to go back down to the surface. And that's just barely south of the main core here. But these cells are still kind of young, and they haven't really had much of a chance to start organizing yet. Okay, let's look at the surface data real quick. I'm using a digital atmosphere here. And I've got some radar data plotted here, and I'm going to put on, let me grab the latest observations for 2 p.m. Okay, we've downloaded the latest data. We're waiting for that to ingest into the digital atmosphere program. And we're ready. So here's the surface data. And a couple of these plots are going to be bad. I'm going to get rid of those. Okay, so the dew points coming up into this area of storms is in the 60s. So the 60-degree isodrosotherm looks like this. And this is bad data here. So we're looking at something like that for the 60-degree isodrosotherm. 64. It's going to look like that. 62, that'll be in between, kind of like that. So I'm kind of developing a picture of what the moisture field looks like here. So 66 about there. And then we'll try to figure out where the moisture axis is. It appears to be a very broad axis, but I think we've probably got one little axis out here and then a secondary one out in the Brownwood Abilene area, kind of like that. Okay, how about boundaries? Do we have a dry line in play today? We take a look at the dew points out here, and yeah, certainly we have dew points in the 20s and 30s. How about the temperatures? Is it possible this air here could be air behind a cold front? Well, if I go from east to west, I see 77, 77, and then it falls off to 65, 63 here. So yes, I think we are looking at a cold front. Somewhere back in this area, possibly. We go all the way to Las Cruces and Deming, 55. So yeah, this is definitely of North Pacific origin. So it looks like we have a dry line. I'm going to go just roughly like that. Probably a cold front further back west, kind of like that. And then I think we are looking at an east-west warm front along the Red River area. Best way to find that is to go from south to north like that. We can see at the bottom part of that line, we have low 80s, very warm. But in northern Oklahoma, we have temperatures near 60. That's off the top of the map there. So somewhere in between, we do have a front. So let's see, what if I'm driving up I-35? I pass Waco and it's 82 over 68. 79 there at Hillsboro. 76 at DFW, still fairly warm. 70 at Gainesville. 70 at Ardmore. And yeah, we're starting to fall off now. 65 at Norman. And we get into upper 50s. So there's probably a couple different approaches we can take. We could stick with the southernmost area of warm air. So technically you could probably do something like this. Is that representative? I don't know, it could be. So we're going to bear that in mind. We've probably got a stronger boundary up here in this area. So from Wichita Falls, 69 here, down to 61 at Chickasha, 54 there. Yeah, most likely this is what we're looking at for a boundary. So I'm going to keep both of those in mind. The big problem that we have is we don't have much convergence along either boundary. The wind field north and south of the boundary, southeast winds. So we'll probably keep an eye on that and see if that firms up a little bit later. It would definitely help to have some better data in this region. Now, there is a source for this data, and that's run by Texas Tech. And let me bring that up for you. Texas Tech Mesonet. You can put that in Google. And that'll take you to this West Texas Mesonet site. And I don't know who runs this now. I know Bruce Haney. He was a pretty well-known chaser back in the 90s and early zeros. He was heavily involved here with the West Texas Mesonet, and I think he had a big hand in getting a lot of this started up. So you just pick your poison here, and we'll go with Lubbock. And there we go. We've got a ton of data. And this is from Texas Tech's Mesonet. Okay, so we can use this to help figure out where that front is. Yeah, look at that from Abilene. At Dyess Air Force Base, we see 76 with the winds out of the south, and then a much more easterly component up around Stamford. So this is a possible boundary right there. We will keep that in mind. And it's possible we may have another boundary up here, but there up in this region is actually pretty cool. 57 there. I don't know what station that is right there. 60 here. Yeah, this is all fairly cool air. So I really think maybe the main boundary is down in this region. So just north of I-20. And I'm kind of comparing that to the larger scale picture here. So let's see. I'm trying to see if that will extend all the way back to DFW. I think we can definitely support a boundary between DFW and Ardmore and the Arbuckles here. So yeah, maybe we have a setup kind of like that right there. Okay, anyway, that can be important because your higher theta E's are going to be just south of a boundary like that. And as you get upper air energy working on this region right here, that will tend to enhance convergence along boundaries like that. And that can back the winds further. And you can really bring up your storm mode of helicities in very local areas, like just north of a boundary, like the one I just showed you. Okay, so let's check out some of the other information here. I can see the dry line coming up from the western counties here. Let me just do a quick analysis, and I'll try to figure out where everything is. Yeah, I think we're looking at a setup kind of like this here. So one boundary out here, the one I just showed you earlier, then this other one up here. Maybe kind of a complicated setup here. I can see some north winds coming through this area right here. But once we get south of that region, we pick up the very stout westerly winds. And this is the dry line air around the Andrews and La Mesa area. All right, let's look at a few other products. We can go to the upper air data. So there's our big low coming out of the Four Corners area right there. This is the 500 millibar chart for this morning. So there's our polar front jet coming up from El Paso up to the Amarillo area. Here's a quick look at the visible imagery. That's showing the storms developing along that little front. This is the GOES-R data. GOES 16. A little bit messy here, but let me see if I can go back to just when these storms developed. That might be kind of cool to look at that. I'm going to bring this back to, let's see, I'm trying to convert, they use German time on this website. So I'm going to go back probably about 3 hours and check out what was going on in the Lubbock area. Okay, so there we go, that's 3 hours ago. Let me zoom that out just a little bit. So you can see what looks like some very overcast layers of stratus and stratocumulus around the Lubbock area here. So it looks like, yeah, looks like they had a bit of a cold air mass covering this region. Let's go back a little bit further. Let's go back one more hour. And I like doing this because it gives me an idea of the origin of a lot of these boundaries and lets me look at what was going on earlier. Because that can point me to which, that can really help me isolate things that might be important later on as I go through the analysis process. Looks like a little bit of an elevated storm here in the Big Spring area. Now I'm going to go forward a little bit. I'm going to go back up another 2 hours. We see the drier air coming in from the west around Midland, Monahans, and Hobbs, eroding a lot of the moisture. And then we see a little bit of a convergence line southwest of Lubbock there. And I think that was probably where we were seeing initiation a couple of hours ago. Yeah, there's our initiation right there. So that's going to be about 2 hours ago. So again, we're looking at GOES-R data. This is half kilometer resolution. Okay, so anyway, that's some neat stuff there. I think it's time to look at some of the thermal data and the upper air data also. This is the 1,000 through 850 millibar thickness, and this will give me an idea of where the fronts are according to the synoptic scale data. And I think this certainly supports a warm front in the North Texas area. I remember last night we had a cold front come through, and that kind of went quasi-stationary in this area here. And I think we're seeing that retreating now northward as a warm front. And so there's the tail end of that in northwest New Mexico, northeast New Mexico. Okay, yeah, I think we can check out a few soundings also. This would be a good time to do that. Let me go over to UCAR for that. Their soundings are slightly they're a little bit more aesthetic, so if we're going to go through a few of them, I'd rather use UCARs here. So here's the Midland sounding for this morning at 12Z. And before I get into this, let me just take a quick look at chat. We got Greg S. checking in. Brett Dean says, thunderstorms this morning in southern Jersey, 59 degrees. Andrew checking in. Ryan Toomies is here. Watching the sails pushing up north of Abilene into the Panhandle. Sue M checking in, asking, did this just start? We've been going about 20 minutes here. We've got Greg S. and Chris Lasakis. Mike Estwick is here. And Greg S. saying he can see the separate layers of winds looking at the GO 16 imagery loop. Gray and damp in Denver, 53 from Mike Estwick. Okay. Let's check out the soundings for 12Z here. Looks like a classic loaded gun sounding here at Midland this morning. And some fairly deep moisture. That's about 150 millibars of depth. Actually, about 100. About 100 millibars of depth. So that's going to be about 3,000 feet deep. And we can see that the moisture in that air mass is about 10 to 11 grams per kilogram. So there we're talking about mid to upper 50s. Not great moisture, but it's definitely enough to support storms. And let's modify Midland. And I'm going to look at the temperatures we're seeing this afternoon. We see, looks like low 80s, very common. Okay, so let's modify this with 80-degree temperatures. That's going to be about 80 at Midland. Then I'm going to use a mixed layer for this bit of moisture here. That'll give me an LCL about right there. And then our lifted parcel will look like that. So, pretty good cape there. That's going to be about 2,000 cape. But as we've seen, one problem at Midland has been the moisture erosion with that dry line pushing east of there today. Midland already down to 38-degree dew points. So pretty good erosion of that moisture there. Let's look at Amarillo. We know Amarillo is going to be north of that frontal boundary. And sure enough, we see a frontal inversion very close to the surface. So there's the surface. This is about 3,000 to 4,000 feet above the ground. So we see a very humid layer from the ground up to about 3,000 AGL. And then above that, we start getting into the cap itself, seeing a subsidence inversion above that. And just for the heck of it, let me lift a Midland parcel against this Amarillo data. So to do that, I'm going to take that 10 to 11 moisture that we saw at Midland. I'm going to lift that with 80 degrees. So that'll be about right there. We can see a very distinct lack of capping. And there's our little lifted parcel there, plenty of cape. So as we can see, it doesn't take much moisture or heating to get storms going on a day like this. Very weak cap there at 700 to 750 millibars. And that's the reason we're seeing a whole lot of cells going up right now. Okay, let's check out a few more soundings. We'll go to Norman And we know that they're also back in the cold air. We don't see really any capping inversion here. And they do have some moisture, but it's a bit on the weak side there. That's going to be 40s dew points there. And then we'll go to Fort Worth. Fort Worth has some pretty good moisture. Let's look at the moisture quality. We see it's about 200 millibars deep. In other words, from here to here. And the mean mixing ratio is about 10 to 11 joules per kilogram. Or, I'm sorry, not joules per grams per kilogram. And let's see what's upstream at Del Rio. Much better moisture, about 200 millibars deep. And we see the moisture runs from about 12 to 13 on average. Yeah, I'm going to go with 13 for this here. So that's the mean moisture profile. And that's what could be advecting up into our targets later on tonight. So here's Del Rio with that higher moisture. It's representative of what we might have out in this region, and that's going to advect up towards these storms as the afternoon goes on. Okay, another way to assess moisture quality is to go to the models. I've got the high-resolution rapid refresh model up, and let me take a quick look at the menu off to the left. I think I may have to go to another model because they don't supply the dew points aloft on the HRRR. I'm probably going to have to go to maybe the GFS or something. Telephone call, how about that? Give me just a moment. Okay. So anyway, let's check out the. Let me check out the upper air products. I remember one of these model charts here had the upper dew point, and I'm trying to remember. Yeah, here it is. See, I'm looking at this chart here under upper air moisture. Their GFS had this 850 millibar dew point and 925 millibar dew point. And I think those are very helpful products. And I think we might have that on the NAM. Upper air moisture, yes, we do. Pivotal weather to the rescue. A lot of weather websites, they don't give you this data. They'll give you the relative humidities aloft. Almost every website has that. Nobody gives you dew point. And I think that's really important for severe weather forecasting because that gives you an idea of your moisture depth and the moisture extent aloft and where it is. So now I've pulled up the 925 millibar dew point. And towards the beginning of the run, this is going to be fairly accurate. So here we're looking at 18Z. So this is going to be your 60-degree dew points up at 925, which is up about 2,500 feet. Then we just run that forward real quick. Oh, good grief. Sorry. Let me see what unknown caller wants. Okay. I think that was a telemarketer there. Anyway, we can see the moisture axis basically runs from about San Antonio up through the San Angelo area up to maybe just west of Abilene, and maybe a secondary pool in the Fort Worth area here. So this is giving me an idea of moisture quality just above the surface, up at about 2,000 to 3,000 feet. And let me just run this to the end of the day. Yeah, see the moisture axis really comes up quite a bit there at Abilene. So it looks like this moisture down in the San Antonio area is going to be kind of important as that moves northward this afternoon. Okay, then let's check out the 850. This is up at about 5,000 feet. Okay, I'm looking at the scale here. The medium green is going to be about 50-degree dew points. And then the very small spots where we have blue, those are 60. So the moisture axis early this afternoon mostly focused on the area from about Uvalde down through the San Angelo area and up to Lubbock. So right here. And we see the moisture is a little bit weaker as we go east. But it's definitely there. This is low 50s dew points. And that was confirmed by the soundings there at Fort Worth. And then we see the moisture really picks up, 60-degree dew points, flowing northward at 850 across Abilene. And then by 0Z, mostly focusing on the Abilene area northward. Then it looks like the dew points are a little bit weaker as we go through the overnight hours. Okay, so that's another way you can modify your soundings. You can, as I mentioned, you can get your dew points directly off these and use that to fill in the unknowns, especially in between the sounding sites where we don't have any coverage. Okay, let's take a quick look at the upper air dynamics and see what's moving through the area. GFS, probably not the best model to use. I'm going to use the NAM. That's weird. I'm looking through their list and they don't have a NAM CONUS. I guess I'll just pick North America. Okay. Well, for whatever reason, we got CONUS anyway. So there we've got the upper level low this morning over the Four Corners area right there. And we can see a pretty good jet rounding the base of the trough just south of Tucson. And then as the day goes on today, there's 21Z. That's 4 p.m., so we see stronger winds coming out of the far west Texas area. We see a couple waves moving across that area of West Texas and the Panhandles. Then by 0Z, looks like a couple strong waves starting to come across that area. And then overnight, the bulk of the energy comes out into the North Texas area right there. Okay, we can take a quick look at the the high resolution rapid refresh model. I'm going to see if their 18Z charts are in. But we can use this to kind of get a general idea of what kind of evolution we're looking at for this afternoon. So this is the chart for 19Z. You can see we've already got a little bit of a difference between the actual weather patterns there's the actual weather and what the model has. This is the high resolution rapid refresh model. So we're actually a little bit better filled in with storms down in this area here. But we can kind of still use this to get an idea of the trends as the model run goes on. So we can see a lot of storms here moving northward. Looks like they're moving up and over the cold dome in the Childress area. And then some heavier activity developing closer to I-20. And you can see that they're very numerous here, especially as the main dynamics start coming out of far west Texas. And that's a result of the weak capping. And then these form up into a pretty good MCS, all the way from Oklahoma City down to Abilene and down to Sanderson. And those move eastward overnight. So probably by the time we do the 8 p.m. webcast, we're going to be looking kind of like how it shows you there. Then by dawn, well, we don't have the dawn hours, but we do have 09Z. This is about 4 in the morning. We can see a good squall line coming through Oklahoma City, through Dallas, Austin, and San Antonio. So all those areas, they'll be seeing this line coming through later during the evening. Okay, let me head back to the radar data, and then you can already see it's filling in here. Very weak capping and numerous cells there. Okay, let's see here. David Holcomb asked how long the stream has been going, about 30 minutes. Yeah, I brought it online about 2 o'clock. In fact, I just decided on the spur of the moment at 1:40 to bring it up. So this was a very short notice thing. I just decided to put it on and see how it went. And you can always watch the replay later, that's true. Yeah, let's check out some of the SPC discussions. This is probably a good time for that. So we've got a moderate risk out for the northwest Texas region. So basically from Wichita Falls up to Childress and then southward to about Stamford and Aspermont, north of Abilene. Got a couple watch boxes up. These are just severe thunderstorm watches. So basically all of the Panhandle and much of West Texas here. And let's check out the convective discussions, because this shows other areas that they're watching. So it looks like possibly some upslope storms around the Clovis, Tucumcari area. And then this region around El Dorado, Texas, down to Sonora and Ozona. Maybe a little bit west of there. Okay, back to the radar. We've already got one of our first tornado warnings for the Crosbyton area. Let me get that centered for you. There we go. So this is the storm that has the tornado warning on it right there near Crosby. It doesn't have a classic supercell structure or anything like that. Storm out velocity. Yeah, you see that there's a little bit of a couplet right there. So a little bit of an embedded circulation in that storm there. Let me set my motion vectors real quick. So I'm going to put a little mark there for that little circulation right there. You can see we've got 33 out and then 46 in. That's about 70 knots of very tight shear there. And that's kind of on the backside of the storm. So it's kind of maybe a little bit of a bow echo type thing going on here. Very small scale one. Then I'm going to go backwards and see what we have. See if there's any consistency with that couplet. Now it looks like this pretty much just formed, but you can see a larger scale circulation in here. There's very strong velocities going towards the radar and some very strong outbound. This is kind of like a large scale meso here. And there's what that storm looked like earlier. So it's actually kind of like a little bit of an HP. I think that's probably the parent storm right there. So yeah, that fits in pretty well there. So going back earlier, there's that structure. It's got that kidney bean shape, and you can see that notch on the back side of the RFD. It's that rear flank downdraft coming in. Probably some pretty good winds out in this area here. Then going back further, this is what the cell looked like about, let's see here, about 20 minutes ago. So there's our cell earlier, about 20 minutes ago, pretty good meso. 24 out and about 42 in. And then as that moved northeastward, see, this is a good time to kind of lay down the general movement on these circulations, especially if you're watching things for chasers. You can see we've got a movement kind of like that, about 0.30 or so. And the very last frame has that little circulation, maybe up in this area, and it looks like it's starting to decay there. So anyway, that's what's going on with that. I think maybe the severe potential was probably gone down in that storm there. But let's check out some of these other storms further down the line. I'm seeing a pretty good, what looks like inflow coming into this area here. I'm going to put a marker right in that spot right there. And I guess that's telling us we're probably getting some inflow into this cell right here. So this would really be kind of a mess to be out chasing. And then further down the line, we're starting to get out of the range of the Lubbock radar, but anyway, that's what's going on there. Okay, let's see. What is our potential over the next couple of hours? That's probably what everybody is wondering. And that's going to boil down to the mesoscale patterns. We know that there's some sort of front in this area here. So some of the SPC experimental charts, that would be a good thing to look at there. So let me go over and check that out. Okay. I'm going to go to their Texas sector here. So this is showing that line moving just east of Lubbock. And they've got a couple of different panels. The one I'm going to pull up is the convergence. It's not that one right there. It's not the moisture convergence one. Let me see here. Yeah, I'm sitting here looking for a chart that had pure convergence, and I could swear it looks like they moved, something got moved around here. Okay, divergence and vorticity. Maybe I just wasn't seeing it. Anyway, there we go. You can use this to a certain extent to find your boundaries when you're going through the surface data and trying to find your fronts. You can see that this has surface vorticity and divergence. And a lot of times when you have a boundary across an area, you're going to have convergence along it, like where we have this red showing here. That could be a potential boundary. The wind field suggests some very strong winds to the south of that, 15 knots in this area right here, coming up on slightly backed flow here, and the winds are a little bit weaker. So that's causing the algorithm here to identify some convergence in this area here. And so looking at that on the chart, that might alert me to look for a boundary in this area. Now, it doesn't look like it's showing that one boundary north of Abilene too well. So I think we're kind of working with the Mesonet data there as best we can. And the other thing we can look at is the satellite data and the radar from DIAS. So let me pull up the DIAS radar and see if I can see a boundary through that area. And while that's working, I'm going to look at the GOES-R data. And what I would be looking here is for a transition in the cloud textures from south to north. Now, sometimes it will show up and you can actually see a line where a boundary is located. But in a situation like this where we have a lot of broken to overcast layers, you're looking for changes in the cloud patterns. And it looks like there probably is something here just north of Abilene. We can see what looks like maybe some transverse banding to the north of there. And what we have down in the south, this is more, looks like maybe more open cells south of that region. Let me refresh this image real quick and see if we have any current data. Yeah, looks like we do. I'm going to zoom this in on the area just north of Abilene. So this probably suggests the presence of a boundary through this region. We can see to the north, things look pretty capped. I wouldn't say very capped, but it looks like something is suppressing development through this area. Maybe a little bit of localized capping in that area, maybe. And then we get south of that, and this is where we pick up more of the open cell type convection in the Abilene area. So this to me suggests that there could be a front in this area right here. So this would have a role of setting up your targets for later in the afternoon. So maybe I would want to stay close to this boundary, maybe north of Abilene, and just ahead of these cells coming in from the west. And then on these satellite loops, we can also look at trends. We can run animations on this. And let me do that real quick. I'm going to load up a few frames here. We have the benefit here of satellite data every 5 minutes, which is just remarkable. And if we animate that, we might be able to pick out some more features in that area. And I'm not really seeing anything here. It just looks pretty messy here. I can see one potential boundary in this area, and then the other one just north of Abilene in that area. So now we've got the Dias radar up. Can't see anything on the animations here. Unfortunately, we're running in precip mode, so this isn't very sensitive to the presence of boundaries, but I think it's present somewhere in this area right here. Spectrum width will sometimes pull it up. I don't see anything there. And velocity. Do we see any changes, any wind shifts? And not really seeing anything here at Dias. This is just showing a southeast flow with a little bit of turning there from the surface up to about 1,000 or 2,000. And then finally, one more thing we can look at. We can look at the VAD wind profile. So for this one, we can go to Ecology DuPage. They've got some good radar data there. We go to Weather Analysis Tools and then to Satellite and Radar. On the left, we pick out radar sites, and we go to Dias. And that brings up the current radar. And then I just click on the VAD wind profile. So you can actually use this not only for looking for possible boundaries, you can actually use this to modify your hodographs and your soundings. Because this right here, it's showing your 0 through 1 kilometer profiles. So right there, that's the 0 through 1 kilometer layer. And we can see that there's a little bit of slight bit of turning. There is some higher speeds aloft. We go from 15 to 30. So that would probably bring up some of your storm relative helicity numbers. And as far as that boundary goes, I was looking from left to right. I was trying to find changes in this low-level wind vector here. And it looks to be about the same here. So that boundary is pretty weak, and all we've got to go on is this West Texas Mesonet data here that seems to be sort of showing it. So there it is right there. Okay. I'm probably going to take a break here and maybe come back in about maybe an hour or so, maybe around 4 o'clock. And we'll look at this situation a little bit more. But hopefully that gives you some good stuff to look at I'll take a look at one more. Take a look at the chat here just a little bit before I head out. Ryan has seen a mesoscale discussion from SPC. Nocturnal tornadoes expected this evening. So that'll be something to check out there. So maybe we'll do a few webcasts later on this evening. Sue is asking where this is headed. It's heading to the east-northeast towards the Ohio River Valley, but I believe it is weakening a bit. I'll have to look at some of that later on this evening when we do the extended forecasts. Storm tops, quick way to do that. You can either use the storm top product on the level 3 data, or you can just go up to higher tilts like this and then read out the cursor. This is about 45,000 here. Looks like nothing above that. So the tops on these cells, they're about 45,000 feet or so. Getting windy in San Antonio, and good. All right, well, I hope you all have a good afternoon, and I'll try to come back on maybe about 4 or 5. And if we have any big significant weather, I'll try to do a special update for that also. Anyway, thanks, and we'll see you a little bit later.